Hi, everybody. We're going to get started. Tonight's lecture will be by Herwig Baumgartner. A couple of very important things to mention about Herwig. He's teaching here this semester as a visiting critic. His studio is in that corner there. I suspect some of the things he'll show today will relate to some of the things in there. You're welcome to pass by and drop in on that studio at any point this semester. Herwig is joining us from Syracuse, where he's been since 2007. I was right. I should have been more confident. And fulfills a lot of roles there, namely overseeing a lot of the introduction of technology into the school at large and into the coursework. Also importantly to note, he has taught our Syracuse students that have studied in Los Angeles in the fall semester the last 2 years. So some of you might know we have a program now that's available for 5th years in the fall semester and graduate students in Los Angeles and also in Tokyo and Seoul. Herwig's been instrumental in building up some momentum for that program and incorporating our students into the culture at Syracuse, which if you know anything about that school, you'll know it's a very special place. Prior to being at Syracuse, Herwig was at Frank Gehry's office for 11 years, 1996 to 2007. And rose to senior associate. So to be at an office like that for 11 years is pretty significant and meaningful. And I know he was involved with really important projects and played a really critical role on a lot of projects that you probably know and love and revere. Prior to that, Herwig comes from Vienna, where he studied music first before he studied architecture. And I suspect that plays a little bit of role in how he thinks about design. Tonight's lecture will feature a lot of work. He'll speak for about an hour, as is normally the case, and then we'll have time afterwards for some questions from any of you. So please think of something that you'd like to ask after the lecture concludes. And the talk will be organized, I just learned, and I'm excited by this, around materials. So projects organized by the materials that they predominantly are designed around or constructed from. So we'll see a lot of projects. I think what's interesting to note about Herwig's body of work is that it, I think, pretty seamlessly tracks the evolution of, let's say, the introduction of and advancement of digital form and more complex contemporary aesthetics, which I think also mirrors the way in which those topics have been played out at Syracuse, which is, I would say, the leading institution for those types of experiments and investigations. And then also more recently, really meaningfully dedicated to the materialization of things that were previously more comfortably explored solely in a virtual realm. So I think the body of work, if you look at the website, I think beautifully maps like the last, let's say, 20 years of experimentation in predominantly in form and aesthetics, but I think also now in materiality. And I liked that quite a bit when looking at the work, seeing how that evolution of my interest in those types of projects is kind of beautifully traced through the work. So we'll see a lot of it tonight. We'll have some questions, and then we will conclude. Please join me in welcoming Herwig Baumgartner to Syracuse.
All right. Water. It's great to be here. Happy to share a bunch of stuff with you guys tonight. So this is kind of a brand new lecture, actually. And it's I'm going to show both student work that I'm doing with the design research lab and the robotic lab at Syracuse, and work I'm doing with my office. And I'll explain all this a little bit. So it's going to be lots of images, lots of videos, and I hope you guys enjoy it. So I want to kind of start out with the thesis of this lecture. And then I'm going to read that part. Won't read anything else, I promise. Before I do that, I try to time myself so I'm not hanging around for too long. Okay, so the lecture challenges the conventional separation between design and making, arguing that materials are not inert substances and machines are not neutral tools, but participants that influence decision-making, form, and performance. Through project research and built experiments, the talk examines how robotics, AI, and advanced fabrication technologies transform architecture into a feedback-driven practice, where form is not predefined but emerges through interaction, resistance, and iteration. Material behavior, machine logic, and environmental forces are treated as design inputs rather than constraints, shifting authorship from singular intention toward distributed agency. By reframing a practice as a primary laboratory for architectural thought, Matter to Practice proposes an architecture grounded in action, responsiveness, and performative intelligence, one that operates at the intersection of matter, computation, and culture, while confronting the technical, ecological, and disciplinary challenges of the present. So, see if this works. Forward. All right, so, I'm a big fan of technology, and I just want to show two things that about now are 15 years old. Is the introduction of carbon fiber composites to sports. And it has radically transformed at least two disciplines. One is parasports, Paralympics, by the invention of what's called a cheetah leg. It's a carbon blade that basically doesn't try to emulate the ankle, it gets rid of the ankle altogether. And it replaces it through material and shape, right? And the result was that, in I think 2012, Oscar Pistorius ran the 400 meter in 45.07 seconds, which is insane. If you think about that, the able-bodied people were running only half a second faster. So it's a huge leap forward. It kind of like leveled the playing field between people with disabilities running and competing in the Olympics and regular folks. The other kind of sport that I think made a huge leap forward through carbon composites was the sport of sailing, which is, unless you are a sailor, not really that interesting because you don't see it, boats are on the water. But this image is basically a foiling monohull that was developed in 2021 for the America's Cup. It's a 75-foot boat that's completely out of the water. It goes 60, 70 miles an hour at incredible speeds. There's these large carbon wings that kind of come down on either side. Again, it's like totally transformed a boat from being a boat to almost an airplane. So this hybridity wouldn't have been possible without that technology and without the kind of like material and intelligence and innovation. But if we would just reduce material intelligence to something that's purely performative, we would be engineers and not designers. So materials has also the capacity, of course, to evoke emotions and engages you, the senses, invites touch, and it has the power to excite us and move us. It can be sexy and provocational. So about 10 years or so ago, when AI first started becoming accessible for folks like myself, Google had a machine that render farm that you could run models on and train models on. I got really interested in these topographical satellite images of different types of landscapes, and we trained several models on that. And the question, kind of like referred to that is like this was the post-digital era. Like we have been doing geometry for over 15 years. And this was then the question really arose, how do we translate all these textures, all these colors, all these crazy things into actual materiality? And it became less and less interesting to model things in 3D, but really figuring out how this could transform into a material. This is a research project at SciAc where we started looking at these images and then trying to design our own materials that kind of match these images, both in terms of color and in terms of texture and tectonics. So this is an experiment with biopolymers, which is a biodegradable biomass that's made with starch, cellulose, and bacteria. I know this looks kind of gross. That was the start. And so these are some of the experiments with that material. So we started mixing different things into it to produce these textures, cellulose and strings and all kinds of stuff. And then this is another student project working with the same material, now a little bit more refined, designing a wall for Burning Man, which is a music festival in the desert. And the deal with that festival is that everything needs to be biodegradable and done after the festival is over. So just kind of that way. So it started out as making things manually first, began with custom mixtures, and then getting the stuff in an extruder onto a robot to make the material. And it was always important here to have an idea of tectonic, not just materiality, so how pieces fit together. Just petting the robot. From that point on, we really tried to kind of like scale this idea up and move into a different kind of material, which was ceramics and glazes. Same idea, trying to basically look at these images and see how we can make sense out of them. And this is kind of a breaking down of an image onto both in terms of like texture, tactility, shape of tiles that were generated. So basically going from image to drawing to toolpath to simulation to actually running the toolpath on the clay piece and then basically getting these textures on it. What's important, so to understand, these are a bunch of samples. We, as you can see, glazes are really an amazing material. They're not just paint. It's a chemical reaction where minerals fuse, right? And so it produces incredible textures. If you know what you're doing, even if you don't know what you're doing, it has a pretty incredible outcomes. Textures, colors, etc. So we had this workshop with glaze artist Christine Jetten. She's Dutch, works with OMA and the UN Studio, Morphosis, all kinds of architects to develop custom glazes. And it was a little bit like alchemy, for us. Because glazes, when you apply them, look nothing like when you fire them, right? They look quite dull when you put them on the tiles, but when you fire them, they become really incredible. So for us, this was kind of a way to bring this very, very old technology kind of into the kind of 21st century by looking at combining this with robotics and AI. So this was kind of pivoting to robots as a design tool. This is a ceramic piece by George Orr, ceramic artists of the 19th century. This is like 1880s, 1890s. He was also called the Mad Potter of Biloxi, Mississippi. And he kind of like was the precursor to American abstract expressionism. So he was like playing with ideas like accidents, things falling apart, like folding, slumping, etc. So not conventional methods of making ceramic art. And so we were trying to be inspired by that and kind of trying to find what would be the 21st century version of this. And we started, bought a clay printer. It's cool, mounted it to the robot. My office had a big CNC setup that had the same kind of setup. So we were doing things in parallel. And this is kind of a video where you are introducing your you're designing a toolpath where there is going to be accidents happening like this kind of slumping or collapsing. And so we would do this on purpose and then fire the piece, then scan it, and then basically use that as a point to work from. It's something you would never be able to design in 3D or in the computer because it has to do with gravity, has to do with the wetness of the clay, how you print it, etc. This is kind of the fired piece. Now, the other kind of computational angle of this was we were like, how do we glaze these things? We could either paint them by hand, which we have done plenty of, but I was really inspired by Jackson Pollock strip paintings. And so we were trying to see if we can make a robotic toolpath version of it, which we did basically feed these glazes into the extruded tubes, and then in a similar kind of fashion designed motions and patterns of how you would drip the kind of glazes onto these ceramic pieces. And this is on the left is basically one of those strip paintings on the ceramic piece, and on the right you have the kind of fired final ceramic glazes. And the third component of how we use tools and in the kind of in that influence is to transfer patterns and lines and from images directly into a router and be able to cut into the ceramic piece. Now, it depends a little bit of the consistency of all this stuff. So what you get is also things like this. If the clay is really wet, you get this amazing like ripples and very crusty kind of surfaces. So it's about knowing the tool and the material to be able to manipulate it in such a way that it becomes a design tool. It's no longer a tool that's used for manufacturing or making stuff. It does that too, but it really produces something that's new. You touch that and it's sharp, and, edgy. This is another example of like, you can see this part on the lower right here, where this was intentionally designed to fail, essentially, right? So kind of producing tool paths that behave and then misbehave, like in this area, or where you slow things down and all of a sudden it starts producing this kind of lumping, etc. So these are also like techniques that we wanted to introduce to really move this away from just 3D printing stuff and really having the robot being part of the design process. This is a student of mine, last year's MArch2 thesis project. It's just a small part of it, but I kind of just want to show you the kind of innovative stuff he was doing with ceramics. He designed this whole tower that collects water for the coast. So it was a huge model, won a grand prize at the AIA convention last year. I think I have some sound here, actually. Or not. I lost my sound. Okay, so there's some sound with this. But gives you a sense of like the kind of assembly processes and also the kind of like using the materiality in this kind of way. So what he's saying in the video is basically he discovered that they were, in order to kind of like stabilize these shapes or these kind of textures, he had to basically double print, produce these kind of like secondary walls to stabilize the pieces so they were stackable, and then ultimately they were filled with concrete for like a structural stability kind of thing. Okay. As I mentioned, so there's, I guess, this symbiotic relationship between teaching and practice, at least in my life. And there's two kind of places where design research happens for me. One is in my office. We founded a small design research department called RAM Division, stands for Robotics, AI, and Advanced Materiality. And then also, of course, at SciAg, I run the Design Technology Department Robotics Lab, which do kind of very complementary types of things. So as Carl mentioned, I organized this lecture by materials, which was actually a funny way to kind of even looking at my own stuff again. And so we're going to go through plastics, metals, ceramics, and wood at the end. At the very beginning, we worked with a plastic extruder and a robot, actually multiple robots. And I did a couple of projects that had to do with prosthetics. These kind of so-called super prosthetics were basically combining two motions into one, and the students had to come up with an idea of how that kind of limb would function. We did a similar thing for animals, combining different traits, combining goats with horses and rhinos with tigers, all kinds of stuff. So this was basically a way of making something that's is made with a plastic extruder, but it's not a 3D print. And I'm going to explain in a second how. Then we did a whole series, what's called Animal House. This was like habitats for little creatures that are endangered species. This was for bats. This was a pangolin house, and then there was one for a sea turtle. Now, the way how this was made was, we were thinking of how can we get rid of this kind of layering that you get from a 3D print. So this work operates with actually having a mold, and you're printing on top of a mold to be able to produce a tectonic, a pattern, and two, like series of components that you can join together into a larger thing. So this is the kind of formwork for it, the overprinting. And then there's a process where how to get the textures onto that plastic that's called hydrodipping, where you basically get a texture onto a bed of water and you can dip the part into that and basically transfers the pattern onto the parts. So this is the kind of colors and textures that you get from that. So we did a bunch of those. At the same time, in my office, I approached this slightly different. This is an installation that I did at SciArc now almost 10 years ago, I think, called Apertures. And Apertures was on a couple of different levels where we were looking into design research. So one aspect of it was looking at Apertures windows that challenges the notion of an architecture opening as a static object. It aims to redefine the DNA of a window, both in terms of its appearance and materiality, as well as its nature as an object. And then the pavilion itself was designed to physically engage the visitor with the architectural work through sensors and sound feedback loops and creating an immersive spatial environment for the visitor. Then there's another aspect to it. We were really interested in making something that's extremely thin and has no structure, or where the geometry of the piece is the structure. So this is a 20-foot tall piece. It's only 1/8 of an inch thick. And the only thing that's holding it up is its geometry, right? So these are 233 panels. They're joined together. And when they're all joined together, they become a thing. Of course, this is a long history, architectural history of thin shell structures with Felix Candela, Pierluigi Nervi, and Anton Tedesco, all of which we looked at, of course. Those are our heroes. And so this was kind of like trying to find a contemporary version of that and what that would mean. As was mentioned, I have a music background, so for me that part was really easy and fun. And so we basically installed a bunch of heat and motion sensors within that piece. And what you see here at the bottom left is basically, it's called a transducer. You mount that to the floor and to the whole floor because it becomes a speaker. So when you're in the space, it's pretty loud. You can hear the sound, but you don't really see any speakers, not like here, right? It's like we don't see that, and so that's hidden. And then we used a musical algorithm program called Maximus B to kind of program the whole thing. And let's see if these things are working. It would be nice to. So these are some of the sounds. So the thing is, the more people were in there, the more irritated this thing got. It got to a point where I just had to leave because it was so loud. Anyway, so installation, the different vantage points into the piece, obviously. These are some pictures of how it actually was made. So we did need a wood scaffolding to be able to put this thing up. As I said, only when the piece was completely connected was it actually stable. And this is a short video. I'm going to talk over this a little bit of the making of it, which I thought might be interesting for the students to kind of see the huge amount of work that went into this making of this thing. So there's, as I mentioned, there's 233 panels. Now this is too loud. Okay, it's better. Each one of them was milled out of CNC foam on a mill, and then these parts were cleaned up. We'll see this in a second. So we had, 200 something molds of these pieces, and then each one, this whole stuff was shipped to Warner Brothers. This is at the staff shop. So Warner Brothers obviously has a huge fabrication facility where you can make all kinds of props and things. And so they have a gigantic vacuum form machine. So they pulled 233 panels for us, heat it up. There's a base coat on it, and there's a clear sheet over it. They did this for each one of those molds. I guess the scary thing about this whole thing was we didn't actually know if this is going to work. We knew we had an idea of putting this all together, but we didn't know if this is actually going to stand up. So there was some factor of surprise. These panels were then cut, painted, and then this is the scaffold, and we basically started assembling those pieces. I think just on a formal level, it was interesting for me to see this thing on the outside being very sculptural, very strong, kind of silhouette. On the inside, this is all electronics being put in. On the inside was a very different piece. It was very it felt very open spatially. So it's very interesting. You'll see this in a second. It was jiggly, not just the camera. So when you touch it, it really not that much. Yeah, so this is the interior of it, right? So it's one big space that has these multiple aperture vantage points. There was an opening, of course, inside. And then, of course, there's a roast with Herwig moss. You have to go through that. That's quite fun, actually. A younger me. All right, so we're gonna just skip this. So this is just footage of people looking at Marcelo. All right, so we did this one more time after this, and this was a fellowship, another fellowship of the Los Angeles Department for Cultural Affairs. So we got a grant to reinstall the piece, but it had to change. So we could only use the panels again. In this case, this was a video mapping, also interactive, so you could. It had also sensors that kind of reacted. This next project also is, in a way, a plastic project. So this is silicon-dipped fiberglass. This is a residence, 3,000 square foot residence we added on to and majorly remodeled in Pasadena. There's a couple of exterior pieces. This was the entrance canopy, which is a steel frame with this material called silicon-dipped fiberglass. Essentially a fabric, self-cleaning, highly resilient fabric. We did a garage addition, so that's a cast-in-place concrete roof. A green roof with the same kind of panels. And then we gutted the whole house and opened it up, basically added a pool deck, and things like that. So a couple of different images. The thing could change color, the canopy would. So it had different kind of programmable color sequences. Depending on the mood or the event that the client was planning, it was able to kind of change appearance. This is kind of before and after. So the construction of it, which I'll talk briefly about, this is a 70-foot cantilever steel frame that comes to a single point. Had a huge popsicle foundation that went down, I think, 30 feet. And this was extremely hard to find actually a contractor to make this because nobody wanted to touch this initially. And we found somebody that is a pipeline welder. So they weld pipes really well. They're very, very good with making these 6-foot long welds. If you know anything about welding, those are really difficult to do because steel distorts. And they were very excited about this thing because they're like, that's better than welding pipelines. So I was like, yes, that's good. And so again, this was all modeled in CATIA. That's a software that we use for construction things that are complex. And then these guys took that directly into a robotics CNC machine, and then welded this thing together. Then chopped it up, powder coated it, chopped it up into, I think, 3 or 4 pieces, brought it to the site. And this is installing the kind of light, the LEDs with it and testing them. That's the detail for the fabric. And that's the finished thing. Now, some images from the interior, so I'm going to just say something. I'm going to show a few of those videos. They seem rather strange, I know. This is a part of an exhibition that's currently, if you're flying through LAX, Terminal 7, there's several of our projects on display there, and this is basically called Twilight LA. And it's a journey through residential living spaces designed for LA, deploying AI-generated environments. So the exhibition imagines domestic spaces as sites of mystery and wonder, as staging ground for strange human natural scenarios. And as you can see, there's no people in that, but there's lots of weird mushrooms and animals that are transforming. So this is part of work that I'm doing right now with these kind of different types of environments, using a software called Cozy UI. It's an AI image or video generating thing. So everything here you see is initially modeled, and then the AI basically animates these pieces. Anyway, it's just a fun little thing. Check it out if you're at LAX, Terminal 7. This one, this is El Contento. This is a residence where we spent many, many, many years on. This is was for an Apple executive in the Hollywood Hills, a 10,000 square foot home. The concept diagram is really simple. It has like an open floor plan at the ground floor with like dining, living, kitchen, all glass. And then on top, on the upper level, you have this kind of like flutes that are made out of carbon composites, and each one of those flutes is a bedroom with a bathroom and closet, like a hotel room basically set up. And then in the center, there's a courtyard with an interior garden for sections through this project. Some of the spaces inside. This is basically being in the living area looking up. There's a kind of atrium where you can see the garden, or the little area in the top. It's the bathroom. So this project went all the way through construction documents, permitting. It took over a year to get this project permitted. It was extremely complicated. This is the structural diagram. I was, show that because it's like an iceberg. A third of the project is underground. You don't see it, but you still have to pay for it. Lots of piles. And then basically on top of it, there's like a steel table and then a carbon composite shell. At least so we thought we were going to do that. And this was going to be one of the first projects where carbon composite is used as structure. It's usually not used as structure, but as cladding. There's a lot of projects for that, but like using it structurally was really challenging. We also worked with a really fantastic climate company called Transolar. You may have worked with them or heard of them. They're really amazing group. And so the whole idea was this is a net zero house, produces its own energy, collects most of the water, and is mostly passive heating and cooling. So there was like multiple different concepts. There's a whole custom or unique kind of PV roof that goes with this that produces about 33 kilowatt hours a year, enough to power this house. And here's some of the kind of diagrams. So everything was automated. So it's a shading system. There's a gravity wall, which is a passive heating and cooling system. There was night flushing to get the heat out of in the evening. So all this, all very low energy kind of things. This is the structure. So I explained concrete, steel table, and fiberglass shell. And I had the whole water collection system that would recycle the water collected from the roof. So this is a while ago. This is when this was before this was normal. This was before normal. A lot of analysis for these photovoltaics. We actually wrote a whole script of being able to orientate these panels to get optimal energy out of them. And then I also had solar collectors to heat the water in the pool. So a lot of tech, a lot of engineering went into this house to kind of make it really off the grid. as you have, rarely ever clients that really go for all this stuff. So we started working with Bill Chrysler, who is one of the few people. He did the San Francisco MoMA with no header. He also worked on the Broad Museum, which my student's going to go see in LA. So he's one of the few composite people that work with plastics or with fiberglass. And that's his shop. So he has this gigantic mill. He can make room-sized panels. And then basically there's a layer of fiberglass, a layer of wood core, and another layer of fiberglass to make it structural. And the first hurdle of this was the city said, I'm going to bore you with some LA building department things, but I think they're interesting stories, actually. So it's a type A roof. That means it needs to be fireproof. Of course, resin burns like crazy, right? So we did a test where basically we put a veil, that's fire retardant veil, underneath the gel coat so that it passed the fire test because it burned through the gel coat. And then when it hit the veil, it basically foamed up. And basically stopped the flames. The part that was not solvable was the fact that it was not an acceptable materials to be a structure. So we had to ultimately pivot, and I'm going to also in my lecture pivot to the next material. But before I do that, I wanted to just show you guys, this is a 3/4 inch model that we built for that house. This was during construction. For my students. Right? That's what we're going to do for our studio. It's a fun model to build, extremely labor intensive. But a lot of things were solved there, like details, lighting, et cetera, et cetera. And I thought, because it's the benefit of students also to kind of show like how something like this is made, So this is in our office. This was a combination of milling parts of the project, 3D printing things. There was a whole like installing the lighting and wiring everything. This is about the size of this piece of that top shell. And then this is kind of the assembly was putting in all the glazing. All the glazing was 3D printed, put the glass in, the model on top. And comes in these big parts after it's all done. And then this is the photovoltaics that go on the top. Lot of tooling required to make this. And then we spent quite a bit of time, actually with each one of our projects, to film them. So this is using the robots for writing camera passes and basically being able to document the work in a way that looks professional. So as I said, pivoting to metal, so we couldn't do it out of fiberglass after all. And I had to go to a company in Holland that was it's a shipbuilder essentially, and they work with quite a few architects, and in the meantime have worked with all the big household names. But they basically are able to three-dimensionally roll metal and weld it onto a crate kind of structure, and that becomes a monocoque structure that's essentially watertight and seamless. They were proposing to weld the entire thing or build the entire thing in Holland, and then chop it up in container-sized slices and ship it to LA and put it back together. That's the detail that they proposed. And the funny thing is, it was actually 30% cheaper than the fiberglass that came out of San Francisco. So aluminum was the way to go. However, project did not move forward. There was some personal issues the client had, and it got ultimately not built, which was a real bummer. This is, I'm going to switch scales. This is a chair we did called the Inside-Out chair. That's combining traditional methods of sand casting something, which is, one of the oldest kind of like techniques of casting, metal casting, and combining that with robotics and with contemporary kind of fabrication techniques. So chair, after it was designed, we made this, sliced it up, and beautiful sections of the different parts of the chair. was one continuous shell. This was milled out of foam, glued together, and then sand casted, which means they put that styrofoam into a sand box, and I'll have a video of that actually, I'll show that. Gets welded back together, grinded, and then it's finished. Also, everything on this chair, including the cushions, was CNC milled. You know, we had like a really good leather person that made all these beautiful looking seams. It's a fun little thing to work. It's the back of the chair, some details of it. So it's combining kind of this rawness of the sand casting with the sleekness of the leather seats. Some images from that. I think it shows also how you make it. Yeah, these are the guys. Amazing. If you want to buy that, it's for sale. We make many of them. So this is basically the welding the pieces back together. They grind it, and then you get this kind of as a finish kind of product. So again, this is kind of combining existing techniques, old techniques, with kind of new processes. This is a kind of different project. This was also a commissioned pavilion for Mextropolis in Mexico City. It's a huge architecture convention. 80,000 people see it. We had, this is the 1800 pavilion after the tequila, and it actually went to the headquarters after this was over. But here we had our dilemma there was that there was none of this kind of tools that we usually worked with were available in Mexico City. Or they were available, but it was really complicated. So we ended up doing, this was with Francisco. I asked Francisco, what is the most common material in Mexico City? It was like rebar, because we do a lot of stuff with concrete. I was like, okay, let's make it out of rebar. And so we did a lot of the kind of design that was all digital in LA. And built this about 25 foot tall, these trusses with these gorgeous drawings. I really love this kind of line work. And then those basically translated into a structure. This is the kind of structural diagram, these 4 big trusses that are interlocking like in rugby. And then basically have layers and layers of rebar welded onto it till it has a sort of kind of plasticity. This is the construction of that project. Installation. This was in Alameda Park in Mexico City for the summer. This next one is, what am I doing on time? Oh, okay, good. This next one is a years of collaboration with a good friend of mine and artist, sound and light artist, Johannes Giordoni. And with him we did, his specialty is producing these immersive environments where he translates color into sound. So he spent like a career on like developing software that helps doing that. There's a whole like tie-in into neuroscience and mental wellness as well that he is involved in. And so he asked us to design this kind of vessel in which that environment can unfold. And so initially, there was like, I think 6 of those planned, and we're working on 1 of them at least now. As they were originally were supposed to be in different environments. This is another LAX video of this thing being inhabited by cacti and creatures and lizards. This is the inside. But it is really made for humans. So, these are just some renderings of the initial ideas. So you have this kind of projection column in the center that we developed that is able to do surround projection in that space, a completely immersive environment. I love that. Hot pink. Unapologetic pink. It's kind of a section through it, sectional diagram. This is, again, working with the Dutch company to produce the panels. So these are different. I know they all look the same, but they're actually quite different. So these are like 3 layers of metal that are compound curved and water jet cut. And so these are different kind of details of how these panels essentially meet. The whole sandwich is about like 2 feet thick. And then that's the finished part. So each one of these layers has different degrees of finishes from rough to polished. And the site of the current piece is in Ojai, in California. It's a slightly smaller version. We spent a lot of time on this door, which when the whole thing is shut, basically you don't see the door. That was the idea. Basically like an airplane hinge, basically, that goes into that thing. And we also had to do a prototype to be able to test if that's actually working, what we thought. So this is a half-scale prototype of that, accurate wood structure, chicken wire, and building paper gets plastered, and that's that light column in the center that is able to project a surround image. It's the finished piece, and that's some of the images when you're inside that immersive environment. So this is like both sound and light that keep on changing. It's pretty spectacular, actually, and it's it was Johannes connected with all kinds of people in the neuroscience world, and so it got a lot of recognition there. This is another metal project. This is a residence in Los Angeles again. This is for a developer that does high-end residential developments. This was a house we designed for them, 5,000 square feet residence. And it's a similar kind of idea, same type of panels, a very large prefabricated panel that get attached to a steel frame. So it's a very fast way of building. So none of this stuff is done in the field, but it's all brought to site and then assembled. Some images of that. And floor plan. There's different layers of it, building steps back as you go up. And this is my very own development, a tent. This is a property I owned in Beverlywood, that's in Los Angeles. There was a duplex on it, and we wanted to convert this into a 10-unit prototype. I know it looks complicated, but in our mind, it actually wasn't that complicated. So it's at its core, it's a Type 5, 4-story building. And then it has this prefabricated metal panel skin that's attached to it. You kind of see this kind of thickening of the outside. So our idea was like this, because LA multifamily housing is kind of a new thing, because we all built everything flat, everybody has their own yard. So this was kind of an attempt to fold the yard into the facade, essentially, so to produce these kind of larger outdoor green spaces for each unit, so that there is this kind of indoor-outdoor relationship, and it's not just a window and a little side balcony. So that was the concept of this. In the thickness of this was basically the landscape of it. Switching to ceramics, and that's going to be a larger kind of thing of work. I'm going to show some work we're doing with students. This is basically over the past 5 years or so. There is one part where we looked at furniture, but then mostly at kind of what we call super skins. Those are skins that are active, bioreactive, or fire resilient. As you know, we have lots of fires. So this is a very current kind of topic still, and we are doing both pretty active research on it, and then also there's a bunch of projects that are related to that. So furniture. This was the initial kind of, this basically a chair is a chair is a chair was the title of the seminar. We made these 3 chairs, and the task for the students on this one was to basically make this with a repeatable part. So they could only have one piece, one part. So 1 or 2 parts was the most. So each one of these pieces you see is basically made as a repetitive thing, so you can connect it into a larger kind of like object or chair. So it's part to whole kind of exercise. This was the bubble chair. Kind of shows the kind of configuration. And so this deploys a bunch of different technologies, some of them traditional, others are pretty advanced. So in order to kind of assemble and configure this thing, we had to use what's called a HoloLens. That's an AR lens through which you can see the digital overlay on top of what you're physically doing. So because these pieces were all pretty unique in terms of like how they had to be assembled, we deployed this basically for assembly and for pattern application to the pieces. This is a traditional thing, slip casting, where you basically pour liquid clay into a plaster mold. The plaster mold absorbs the water, and out of it comes a ceramic piece. This is basically their unit. So that unit was, I think they had 2 of those, slightly different. And on the left, you kind of see the HoloLens, what you see through the HoloLens, which is trying to assemble basically the pieces. And on the right, you see actual assembly. So again, kind of combining mixed reality assembly with traditional kind of ways of making. And this was another way of how to apply the glazes. Basically, she sees through the HoloLens the kind of pattern that she's supposed to paint on. It basically turns into a painting by number. That's some of the images of the final piece. Yeah, these are like gorgeous, gorgeous pieces, beautiful glazes. So I'm just going to show quickly that this is the noodle chair, I called it, because it had only one part, which was a tapered tube that was 180 degrees, but that allowed to do all kinds of configurations and turn this into a chair design. And this was the ribbon chair. Similar thing, we had like 2 components for this. And we're able to assemble this into a chair. Now, the main work, I guess, or the more recent work really has to do with addressing certain issues of climate change and how architecture can be how we can basically mitigate and help lower the carbon impact that architecture has on the environment. And so this class looks at, was a whole series of algae facades. This is one example of it, where basically we have a ceramic kind of screen that has microtubing on it, and so we're pumping algae through these microtubings to produce both oxygen and algae as a byproduct. This is kind of the, so each one of these projects was attaching to an existing building. So this is a typical downtown LA building. This is some of the piling that's developed for that. Again, this is the idea of componentry. So in this case, they had 5 components. They were slip cast. Then put under the robot and basically glaze. This is, again, the drip glazing process that we developed for previously. And these things are glazed and fired at 2,000 degrees, and that's what it looks like when it comes out. This is a great shot, kind of shows you the transition from glazed. And this, you can see the microtubing on here. So this thing was actually working, a working prototype, won all kinds of prizes. It's a real fun thing to do. So this is, we did a bunch of those working with algae as a kind of way to add ceramics with a performative kind of component. And this was one where we integrated photovoltaics into ceramics. So you kind of see that it's kind of a wall markup of producing energy. That's not a panel on the roof, but it's actually integrated into the material. So that was the premise here. And it's both in terms of color, texture, tectonic is part of the thing. It's not glued on or an afterthought. And then there has been lots of work with fire resiliency. So I've been part of a task force at SCIAC that after the last 2 fires, the Eden fire, the Palisades fire, this became a bigger issue. But this actually was after the Wuxi fire in 2018, which was in Malibu. And we did a project with the students to basically, there was lots of animals actually that were affected by it, humans of course too, but there was no shelter for the animals, so a lot of them burned. And so we did this fire resilient animal shelter. is you kind of can see how these videos were set up. So this is always like looking at a problem, an issue, then looking at a region, an area, which species are affected. And then basically a design for it that I think had to do with like, basically producing a geometry that doesn't trap fire, right? And so students were looking at this kind of stealth geometry that is, it's looking like from a barn typology that's pretty flammable in terms of like its geometry, and they were looking at more at this kind of stealth geometry. There's a whole wall buildup that we developed for that. One of the issues with fire is even if you have a fire-resistant material like ceramic is, things can get so hot that things will start burning inside the house because the heat is such that you get like temperatures or anything in paper or anything that's burnable inside the house catches fire. So a big part of this was to be able to produce this kind of insulation, multiple layers, being able to vent out the heat. Some of the processes you've already seen. There's also like a pattern transfer onto the parts. They were glazed and then assembled in this. This is kind of the mapped image that gets broken down into glazes. Then some of those kind of ribbon mills that you saw before, and it gets fired at 2,000 degrees. And then we had a prototype for this that was pretty extraordinary, I thought, both in terms of color, texture, performance. So it's kind of when all these things kind of come together to one thing. That was the final prototype. I'm going to show a couple of projects from my office that are kind of related to that. This is, again, a furniture piece. This is a ceramic table we did out of repeatable components with these deep blue glazes and then metallic glazes on the outside. I always laugh. This is a really fragile table. Very hard to move it. Very unpractical, but beautiful. So, but yeah, this is like one of those things you find out afterwards. Well, we gotta design better stability into these pieces. It's a fun piece to do. As I mentioned, fire resiliency. So I'm going to show a bunch of projects that have to do with that started with this addition to Cornelia Funke's residence. So this is a pretty famous writer, kids book author, Inkheart, Dragon Rider. If you guys are familiar with that, probably you're too old for that. But so she has this huge residency in Malibu where she invites different artists to basically stay there. So there's music artists, visual artists, and her property was very, very close to that fire. So it partially burned. And so after that fire happened, she wanted to, we did a bunch of structures for her that had this terracotta fire resilient skin. And then the glazing parts all had fire shutters. So in case of a fire, the thing would shut down. But the budget on this was such that there was no room for doing anything custom. And so what we ended up doing is we actually picked regular tiles that you can buy off the shelves and put together a color palette like this, and then developed a pattern based on that was appropriate for that kind of project. And we also, this is after the this actually was at the Venice Biennale a couple of years ago, and also got some prizes recently in LA with the whole fire. There was a competition for designing ADUs that are fire resilient. So this is, again, kind of coming back to our expertise with designing these tiles, being able to transfer, not just make it performative, but also make it sensible, so that it has another kind of layer to it. So this is one of the larger ADUs. There's 3 of those. I'm not going to show all 3 of them, but that's where that buildup came from. So there's like geometry of the tile itself. Then there is the kind of like underlayment, the ventilation, and then the insulation on the inside that produces that. So it's 3-bedroom ADU. Does everybody know what the ADU is? Accessory dwelling unit. That's an LA thing. We don't have enough housing. So the state of California actually passed a law that you can build these units in your backyard essentially to increase the housing stock. And so this is all pre-approved by the city of LA. So you kind of go through a pre-approval process, which facilitates if somebody buys them to be able to build them. So you don't have to go through the whole building department approval. But it's basically ground floor is all living, and then there's 3 bedrooms, 3 bathrooms upstairs. Some images of what this looks like on the inside. You know what that is. This is what comes after fire, is the floods. And so, I'm just going to let that play. It is retrieving. There's a smaller version of that same thing. So this is 800 square feet, similar concept in terms of fire resiliency, smaller kind of 1-bedroom unit with a bonus loft on top. And then we also did this also was a Biennale entry actually for 2022, I believe. This is basically a 3 townhouses for Venice. This is a speculative project that is, the concept was to have a very open, because the problem with these kind of vessels is also they don't have a lot of openings, and they are in order for them to function, they need to be pretty opaque. And so we designed this kind of ground floor that's totally open to the outside, and there's garden in it, and then basically be able to retrieve into these kind of vessels that are sitting on top of that open floor plan that is fire protected. It's kind of a floor plan of it. You see this is very different geometry at the ground floor versus these 3 independent kind of objects. I think they're all 3 bedrooms, 3 stories tall. Some images of the kind of looking up into these between the pieces and underneath it. And of course, we did a prototype for that as well to test it. This is, again, the same process that I showed before, slip casting, working with the robots to kind of texture transfer, and then that's glazed, the final piece. How am I doing on time? Oh, perfect. This is going to be exactly an hour. I'm almost done. So I'm going to show 2 competitions which we don't do too many of, but this is the Songdo Library in Korea, which was kind of like trying to reimagine a new type of library, maybe less for books, but more for media, and where the library also becomes more of a social meeting point, I guess, beyond just a storage for books. And so we designed these 3 pieces. They are all clad in terracotta. So this is terracotta lamellas that are able to let light in. So behind it is mostly glass. This is a kind of book stack that's modeled after Indian stepwells, like kind of stepping down space, big vertical space. And that's the concept for producing, dealing with the opacity, transparency issue you have with terracotta. So using the terracotta really as a lamella. What's next? So we just recently really started diving into wood and into timber, and I just wanted to show this project. And obviously we are going to look at what we can do with that material and with that in terms of texture, geometry, and form. But this was kind of a first attempt of looking at what it could look like. This is a museum for literature in Korea. It has basically this, the concept was to have these 5 rocks that are made out of CRT, burnt CRT, that are inserted in this big kind of open space at the ground floor. That's like a passage that's all glass transparent. And so when you see a diagram of it, so you can see the rocks and then the kind of boulevard that is the kind of common public zone, and then you basically descend up into these different spaces for the exhibitions. This is the kind of main entry into it. And so these CRT rocks are hollow on the inside, so you have these exhibition spaces that are basically have a circulatory, spiral circulation into it. Inspired by this is, to me, it was really a beautiful kind of like, this is of 1377, one of the first metal type books, Korea. And that's kind of an overview of this project. So this is going to be something we're going to dive into next in terms of material testing, looking at prototypes, markups, etc. And so on. That's it. Thank you.
Thank you. 1 hour exactly?
Yeah.
Questions? Would anyone? Oh, wow. Okay.
Thank you for the presentation. It was actually really interesting. I was putting Werickel's work. I went to undergrad with him, so I was like, oh, hey, I know who this is.
Yeah, yeah.
I'm really curious about sort of the process you go through in terms of color choice. Like, what really is the biggest driver in terms of the aesthetic appeal towards sort of a palette that you work for, like the previous project, knowing there's kind of a lot of really beautiful reds and oranges? Like, is there a motive to the process on the color palettes you choose?
Yeah, so we discussed this actually quite a bit in terms of like finding a way to have a conversation about it that is not just like I like this or I don't like this. So what we're looking for often is like there's a few things. So vibrancy is one. Composition is another one, right? There's something that's barely ever talked about, but like obviously how things are laid out kind of give clues in terms of like how would that be distributed onto a surface, how much of the blue and the red and how do they interact. Then there's the lines between the different textures, which we often try to transform into tectonics, right? So like that can become a panel, it become a seam, and then there's certain aspect of it, and that's kind of like the qualitative, how I look at these images is when they come out of the AI, is are they still recognizable as something that is obviously a landscape that you have seen before, right? So this is kind of like, how many steps do we have to take to kind of take it away from people just going like, I know what this is, right? So, and there's often not very many. So you have like 1 or 2 degrees of separation from actual to abstraction. And that's obviously, the whole process is a process of abstraction. It means you go from texture, color to an architectural material, an architectural size panel, and a color. And then how to translate those things onto it. And I think, you know, what is kind of came from is we were in that same trap. I didn't show any of that work, the work that was before that. When we did a lot of the digital work in the late 90s, early 2000s, that was always pretty monochrome, you know, and it was kind of like, it was all about geometry. And so there was kind of a deficiency really there. And that it was not just us, it was the students also. They were like, you know. And so there was a real need for, or desire for people to actually get their hands onto materials and be able to touch things, you know, and that's just, it's the shift, this kind of post-digital shift that happened, kind of triggered all this, you know, a lot of this stuff. Yeah.
I really like the music installation that you did. That the thing that you weren't sure that's gonna stand up.
Yeah.
And I have a question. Like, did you guys think of any like structural generation within like 3D printer slicers? For instance, like Bamboo Lab, they have this infill algorithm called lightning infill, in which that is like it prints so geometry that's hollow inside. It's like a tree support, but yeah, I think it's written in C++, but Grasshopper is written in C#, so it's pretty easy to bridge those.
Yeah.
So did you try to integrate any of these structure analysis?
I mean, I noticed, because we actually, there's an artist that I were good friends with that she uses that actually, these tree structures as a way how to present her sculptures. I mean, the purpose of that piece was, can we make something that's as tall as up to that rail out of this material without anything, right? Other than the geometry itself. That was the challenge, you know, and it was interesting for us at that point. So we weren't looking into any kind of support, was 3D printing this thing. And I guess my position about 3D printing out of plastic, anything, which you saw on this sample, I mean, I know these were animal legs, all kinds of crazy stuff, but like it's, you know, I don't find it that interesting. I mean, we already have 3D printers, you know, that do that stuff for us, and they print in layers. So, but buildings are usually not, I mean, you can 3D print buildings, yes, that exists out of concrete, out of plastic. But I guess my interest is more like, how can I get rid of these kind of like recognizable topography lines, like to topo something and print it, and how can I switch that to become a surface? You know, because the opportunities then become infinitely bigger, right? Because, for example, to be able to put openings in it, create patterns, different type of textures, you can't be printing stuff in layers because you're restricted to a singular direction. Versus if you print stuff over a body or a volume, you now have all the freedom to design what kind of panel you want, what texture is, what the color is, all that stuff. So we very early on actually moved away from that kind of topo printing and supporting things to, yeah, it was just not something I was really interested in.
Oh no, I mean like within like the design process, like you use 3D printer slicers algorithms to generate the geometry of it, because like I thought you were trying to make it like.
You mean for the clay printing?
Not for printing, because like you're trying to make the shell stand up. So there are like written algorithms for like structural optimization for that.
Yeah, there was, but it's. I mean, that was run through a program that we were testing that to see if it's stable. Yeah, that's.
Okay, thank you.
Yeah.
I had a lot of fun looking at all these fantastical forms. And as the presentation was laid out in terms of materials, it got me to start and think like how the material affected some of the forms that you're creating. But then I see like every single material that you're able to use, you're able to sort of simulate the same fantastical forms. And it even seems that the textures you're applying on them kind of resemble each other. So how do you kind of grapple with using different materials and coming out with a similar form, and how do you make that decision where which material do you end up using and how does it resemble the forms in the end?
Yeah, I mean, I think the materials influenced a lot of how what we, it was kind of a, as I said in the beginning, it's kind of a decision maker for you, so it's not neutral. And I'm really excited about the wood, because I'm curious what's going to come out of the wood. I like what it looks like, but so I mean, there's, you know, of course, there's always an author, right? You're an architect, you're an author, you have a kind of like idea of what you want to do, but it is not an absolute idea, right? And so when you actually get into working with the material and then start corrupting the material and the tools you're using to making it, misusing it maybe, like, or not using it in a traditional way, then there's unexpected outcomes that come out of that. And, you know, then you have to pivot. You know, you either go like, oh, this was a mistake, and I don't want to have mistakes, I want to have perfection. But I think to me the more interesting thing is like working with robots that produce imperfect things. And that's an opportunity to, I guess you would call it misusing the tool or the material, but it basically leads to other things. And so I'm very interested in finding these other things, you know. And so and it keeps it exciting. And you know, I do have a love for materials and textures, you know. So I do think those things are exciting, you know, and important. Yeah.
It also happens at different scales for each project.
Yeah.
Would you agree with that?
Yeah, of course. I mean, it's, yeah, I mean, the material scale is, I mean, there's certain kind of decisions that are this close, you know. They don't necessarily, I mean, you're saying the forms sometimes look the same. That is true because you're applying it in the, you know, if we are doing like these big rocks, these monolithic pieces, then that's coming from a massing idea, right? So that's going to be less translatable in terms of like how is the, but when you get closer to the material, then it totally changes, right? So it operates on this in these different scales differently.
I mean, I think this is in the similar vein, but I'll sort of approach this through kind of a question like via design build, sort of not suggesting that you guys are contractors, but I'm wondering sort of what your thoughts around the sort of position of architects in relationship to builders / manufacturers, and maybe also in relationship to the sort of business landscape of Los Angeles, because I know you mentioned a couple of times sort of like prop makers and things like that. You know, and I can sort of see precedent in sort of the sort of dynamic forms that you're working with in a lot of architects, but especially like the material, like the chairs and the material explorations you're doing. That sort of seems, you know, outside of kind of like a lineage of precedent where you're dealing both with the material qualities and the forms at the same time. So I'm curious sort of like how you, like one, how your business operates and kind of like where you are in the network of fabricators, builders, producers, and then also just designers and then.
Yeah, I mean, that's a good question. I mean, I have to say, I do love, and we have a long history, well, not long history, my office works with contractors. You know, we at the very beginning often in the design process, and often it's a very specialty. This is maybe something I learned at Gary's, is like if you, most conventional builders will step away from something. They see something like this, they go like it's complicated, and then they don't want to do it because they don't see a profit in it. And so part of the architect's task, and I do believe that, is to find the right match and to find that right match early, you know, so that you're not designing something that is, then you get to the contract and the contract's going to say it's not buildable this way. And so we have a lot of these kind of collaborations, and I enjoy those because, you know, not every contractor, but lots of them that we work with have really interesting ideas and approaches. So, and kind of knowing somebody that knows his tools really well and how to work with them is really, is not something to look down upon. It's actually the opposite of that, you know. So, and so I enjoy that. So of course, we have done a lot of fabrication ourselves, and I have probably doing much less of that, you know, because it's really messy, you know, and it's just like it takes over the office and things like this. So we try not to do that much, but really focus more on making small prototypes and developing the workflows that we can then give to somebody and say, hey, we developed the toolpath script, this is how you can build it, this is the material, and then work with a contractor, but giving them already, it's a really interesting question you're asking, because I do think that authorship of the architect in building is really important. You know, to me, it is very important. To some people, it's not. But for me, it's just critical that we have a say in this, how things are made. And because it changes how, you know, things get watered down all the time. You know, you give somebody a rendering and they go like, okay, well, I know how to build this roughly. And it turns into something completely different. So I absolutely want to have control over this part, because I want to be able to walk up to this column and go like, that is what I wanted, you know? And part of that is to kind of be able to produce a sense of what always amazed me, both spatially and in terms of materials, is like if architects are able to pull off something where you go like, wow, you know, how did they do it? You know, like where there's a sense of mystery to it. Like it's not obvious how it was put together. And so I'm very interested in having authorship in that. And so even if I don't do the stuff myself or can't, you know, I would at least be involved in, or deeply involved into the making of and how they make it. You know.
We will take 2 more questions. We were going to take 1 more question, and I was going to ask it, but then Mehek raised her hand. So I can save my question for dinner. And you guys are both going to ask your questions at the same time, or like one after the other, and then Herwig will close us out with the same.
Just related to your answer for the last question, how do you balance that authorship with the machine that you're using and the uncertainty that you're trying to get from the machine?
I can try. I mean, I would say your comment about being critical of the hands that feed you is very interesting as an architect. But I was curious about the ambitions of the practice in relation to how you're also like definitely a part of academia and how that works. Because I know you talked about all of the materials and the relationship of the material and the form, but to me, there's like a thread that I can sense very strongly, like almost like gravity doesn't exist. That's mysterious and interesting, and yeah.
Yeah, so I'm not sure I understood the question, but are you? But maybe I can answer both really quickly like this. I would say, first of all, to me, teaching is really a way maybe of helping the students to not be afraid of failure and asking questions. You know, so and it's always it's a very rewarding business. It can be also very exhausting, but like mostly it's interesting because if somebody doesn't know all the things that I know, like a student, they will look at things differently, right? But not always is that a disadvantage. Sometimes it's a big advantage. And so you have to be able to foster that, I think, and the kind of like the willingness and the confidence in giving them confidence to experiment with things, you know, and that there's a way to figure things out. You know, there's a way how you can design your way out of this. And so I do think that's very important, and so that's why, you know, there's a lot of stuff we give the students so that they can start working with something. But there's also kind of new territory that you use that's different in teaching than in practice. And to answer your question about how do I manage the kind of making stuff with machines, I make them smaller. Meaning it doesn't have to be big, but it needs to be. It needs to show a contractor or somebody that's going to use that how to make it, you know. So and that goes all the way into the details of questions that you have with somebody that's going into fabrication, because scaling things up has its own difficulties, right? So but if you can't even provide a kind of setup of how they can start, it's a non-starter, because like it will. One of three things will happen, or one of two things will happen. It will be labeled as unbuildable, unfeasible, too expensive, right? But if you can say, okay, you can make it this way, then you do this, then you do that, and then you find different people to do the different steps. Now the person that makes the slip cast can make thousands of them for cheap, right? It doesn't matter what the geometry is. You find somebody that can do the next layer of it. So you have to, I think it's very important as an architect to be able to compartmentalize and help finding different people can do different things confidently, you know, and then you put it back together. And so that's why I think the role of the architect is in terms of being a part of the building process. Thank you.